Hello YouTube, this is a brief overview on how to sketch angles in standard position, okay? You might hear this a lot in a trig course or maybe pre-calc, but we are already familiar with angles. We say angles are these two rays that share a common endpoint. They share this common endpoint here and they form an angle. But basically what we say about angles are these. We say that they have an initial side where they start. And then we say a terminal side where they stop or terminate, okay? So we refer to this as the terminal side. And you can see that this is supposed to be an arrow here showing that I rotated from the initial side to the terminal side, but we say this is some angle, and we could call it the Greek letter theta. Thing is that we deal with angles so often that we want to kind of standardize the practice of sketching them so that when somebody says go sketch a 45, or 30, maybe this is some 30-degree angle just because I just said so. They say go sketch a 30, one other person doesn't come over here and sketch their 30 like this, we want them all to be drawn the same. So if that's the case, what we're going to do is we're going to agree to sketch them in standard position. So the definition is here. We say angles in standard position are drawn such that their initial sides are on the positive x-axis with their terminal side rotated some angle from the initial side. So what we're going to notice is this. We say x-axis. This must mean that we are going to be sketching angles in standard position in the xy coordinate plane. So very quickly, just to recap this here, we say this is our x-axis, this is our y-axis. So angles in standard position must leave the positive x-axis. So we're going to sketch a general angle in standard position right now, but we're going to refer to this as an angle in standard position theta. Okay, so some things that I want to say about theta really quickly. You'll notice that it terminates in quadrant 1. So I'm going to write this down. It terminates in quadrant 1. We spend a lot of our time, as a matter of fact, going through which quadrant an angle terminates in. So we're going to go ahead and label these 1, 2, 3, and 4. So recall that they go in this order. Also this. We could say that this angle theta is less than 90 just the way we've got it drawn, but we notice that it's gone counterclockwise less than 90. So I'm going to label this one as a matter of fact 90, and we'll get back to why it's 90 in a second. But we say it's gone counterclockwise, so we're going to say this: positive angles go counterclockwise. So we say positive angles rotate counterclockwise. It's also retrograde if you're interested. And we say negative angles, okay, just as much as positive angles rotate, but we say rotate clockwise. And I'm just going to leave it at that because I'm horrible at writing with this thing, so we're just going to move on. But anyways, we say, okay, so this must be some positive angle theta. Now, you notice I marked 90 really quickly. We say this is 180, this is 270. This is also called 360, but it's got another name. We say 0 degrees. And by the way, we're going to give these a name also. We say these are coterminal angles. Maybe we can come back to why that is the case. But we say 0 to 360 because they mean the same thing. But we say rotating through these angles, it's kind of nice to know these four right here. So these have a name. These are referred to as the quadrantal angles. I'm going to go ahead and write this out for you here. We say these are the quadrantal angles. And the reason why is because they fall upon like the quadrant dividers. The only reason I bring those up is because really quickly before we tune out of this video here, I just want to sketch a couple of angles here. And so we'll call this like, our first example A, and we'll call this B. We say in the first one we have some angle theta, and we'll say that this is negative 135 degrees, just to start with the negative one, get it out of the way. And we'll call this one theta. And we'll call this maybe 210 degrees. Simple fact of the matter is this: I want them sketched in standard position, which means their initial sides occur on the positive x-axis. So we never had to think about that part. The thing that's different is this. We say, well, negative 135 degrees, how would I sketch a negative 135 degree angle? And the first thing we want to do is we want to assess this situation. We say it's negative, so it's going to go clockwise. But you'll notice that I marked the quadrantal angles up here. The reason why is because, and notice that also in this case, since I'm rotating clockwise, 90 degrees won't be up here, it'll be down here, but we say this is negative 90. This would be negative 180 if I were to sketch these in. Negative 135 is good to know these because now I can say things like this: well, how far beyond 90 should I go? And for anybody that's taken a trig course before, they say, well, this is 45 degrees, more than negative 90. Or we could say 45 degrees less than 180. But those quadrantal angles, what they're going to do is they're going to give me some indication of where I am. Okay, so this is negative 135 degrees. It is very appropriate to label this here, or we can label this out here, 135 degrees. And this must must be negative, okay? And really quickly, 210 degrees. We say, well, I know this is 90, this is 180, so I'm at least going 180. Maybe I notice that this is 30 more than 180, so I could make, when I sketch this, I could make like a, I hate to bring it up here, but we say like a 30 here, even though that has nothing to do with what I'm really sketching, which is this angle right here. We're going to label this again. Theta is 210 degrees. I was able to get there using my quadrantal angles to help me along the way. It's definitely positive, okay? So now the very, very last thing I want to do before I move on is simply this. Talk about this idea of coterminal angles. What do we mean by coterminal? Coterminal means this. Two angles that terminate together. That's what the word means, is terminate together, okay? So what if I could come up with another angle that terminated in the same spot as the original angle? Wouldn't they be the same angle? And remember, we refer to as 0 and 360 as this, because look at this. If I sketch a 0-degree angle, it looks like this, 0 degrees. If I sketch a 360-degree angle, it looks like this, 360 degrees. You notice that I landed in the same spot. So two angles that land in the same spot, by definition, we're going to call this coterminal. And the question is, well, how do I find coterminals and why do I want to? So I'll switch over to red here just to show you, first of all, why I want to. Maybe this. Maybe I don't like to deal with negative angles, and I want something that just has to stop in the same place, but isn't called negative 135. I say, well, could I find this guy right here? And what you'll notice is, well, like a full spin here, a full spin would be 360, right? And we know that just this portion right here, this portion here, is negative 135. So maybe we could do some math and we say 360. If I were to take away 135 degrees, that would leave behind this little red portion that I'm trying to find here. So we say 360 minus 135. And we get left behind with 225. So what I want to see is this. Basically, this red angle in here, I'm just going to make sure I'm on red. That angle is 225 degrees and is coterminal to negative 135 degrees just because of the sheer fact that it terminates in the same spot. So the only thing that I really want to mention here is this. How does one find a coterminal angle in general? So we say coterminal finding, this is how you find a coterminal angle. But basically, given theta, an angle, okay, just add or subtract 360 degrees. And this is all we need to do. It makes reasonable sense to think that if I have a 210-degree angle, here's this one right here, and I add on another 360 degrees, I land in the same spot. So in this instance, we say coterminal with 210, we say 360. If I were to add these together, I would get 0, 7. 2 plus 3 is 5. So if I were to sketch now a 570 degree in standard position, forget the color changes here, but we say to start here, it would rotate positive 360 degrees, plus how much more to get up to 570? Well, we already know it's 210 more. But if I were to rotate 210 more, that'd be another 180, plus that 30 we went already initially before over here. But you'll notice that it's coterminal too. And then this is a 570 degree angle, and all we had to do to get it was add 360 degrees to it. So there's a brief overview of angles in standard position. Cheers.